All right, let's review concentration because we're going to need to recall all of these calculations in order to do the calculations involving colligative properties. So this is kind of like a twofer. So let's review this just to kind of refresh your memory. As we talked about, we know that concentration is the amount of either solute or solvent, amount of solute divided by the amount of solution or the amount of solvent, in which case we're talking about molarity, percent by mass, mole fraction, or molality. And you can use them as conversion factors if need be. So we're gonna perform a calculation for each one of these values: molarity, molality, mole fraction, mass percent, given the following information. We're gonna use 0.0123 moles of ammonium carbonate solute, which has a molar mass of 96.09 grams per mole. The mass of the solvent is 35.12 grams, and the mass of 10 grams of solution is 11.7 grams. So in essence, this last column represents the density of the solution. Okay, so let's start with molarity. Moles, what we need is moles of solute over liters of solution. And the moles of solute we already have. That's literally given in the table. So that is taken care of. What we need, however, are the liters of solution. Okay, so in order to do that, let's take a look at what we have. The moles of the solute are taken care of, so that's done with. But for the denominator, the liters of solution, this is the pathway we need to take. We have the mass of the solvent, so we need to use the mass of the solvent along with the mass of the solute to get the mass of the solution. And once we have the mass of the solution, using density, we will determine the volume of the solution. Alright, so what that basically implies is that we need to change the moles of solute to mass. That's actually the first thing to be done. So we have moles on top. We make sure to place moles of ammonium carbonate on the bottom, since this is the solute. And the 96.08 grams go on top. This will cancel out the moles and give you the mass of the solute, which is 1.18 grams of ammonium carbonate. Alright, then the mass of the solution is basically given by the sum of the mass of the solute plus the mass of the solvent. So the 1.18 plus the 35.12 grams together give you 36.3 grams of solution. Now that we have the mass of the solution, we use the density of the solution to change to volume. And here's where we place the 11.7 grams on the bottom, the 10 mLs on top, and then we change the mLs to liters simply by dividing by 1,000. Okay, so grams of solution go away, mLs of solution go away, and now we have the liters of the solution. And the last thing to be done is simply to plug in the values. Divide 0.0123 moles of solute by the 0.0310 liters of solution to yield a value of 0.397 molar, which is the molarity. Alright, moving on, let's do the same thing for the molality, where we need moles of solute over kilograms of solvent. Now the moles of solute we already have. The mass of the solvent we do have by this in grams, so the only thing we need to do is change the mass of the solvent to kilograms. So we will divide the 35.12 by 1,000 to turn that into kilograms, and then we simply input that values into the equation. 0.0123 moles of solute divided by 0.03512 kilograms of solvent, meaning that the molality is 0.350 little m. Alright, next one in the series, mass percent. We need mass of solute over mass of solution times 100%. Now the mass of the solute we don't have. Initially we just have the moles of solute, so we need to change that to moles of grams of solute. And once we have the mass of the solute, add it together with the mass of solvent to get the mass of the solution. Technically speaking, we've done all of these steps already when trying to find the molarity. So I'm just going to depict it here one more time. 1.23 moles gets multiplied by the molar mass to yield the mass of the solute. And adding the mass of the solute with the mass of the solvent yields the mass of the solution. So here you simply divide those two numbers, 1.18 grams by 36.30 grams, and multiply by 100% to get 3.25% of solution. If the mass percent was ppm, instead of multiplying by 100, you will be multiplying by a million or 10 to the 6, and the value will be in ppms. And if you need a ppb, then you multiply by 10 to the 9. Alright, the last one in the series is the molality. The molality is moles of solute over moles of solution. And remember, the molality is given by this symbol chi, which looks like a big X. Alright, so the moles of solute we already have. We don't need to calculate that. The moles of the solution, however, we do need to calculate. And to get to that, we need to take the mass of the solvent, change it to moles of solvent, and moles of solvent plus moles of solute will give you the the moles of the solution. Okay, so here we go. The moles of the solvent can be given by the 35.12 grams of solvent, aka water, divided by the molar mass of water, 18.02, which is equal to 1 mole. So this yields the moles of water. Then you add the moles of water with the moles of solute to yield the moles of solution, which in this case is 1.961. And at the end, you divide the moles of the solute, 0.0123, by the moles of the solution, not of water, by actually solution. So this is moles of solution at this point. Alright, so we get a value that is less than 1, in this case 0.00627. Okay, so that's a very brief and kind of fast review of concentration, but hopefully that helps refresh your memory. For sure, we're going to be calculating molarity, molality, and mole fraction. So those three are very crucial when determining colligative properties. And speaking of which, we'll talk about colligative properties in the next video.